Hello, welcome to today's webinar. We are happy to have you with us for this Best of the Forum session, Decarbonization Technologies, What We Have, What We Need. This webinar and the others in the Best of the Forum series are sessions that were highly rated from the 2019 Getting to Zero Forum held just over a year ago in Oakland, California. I'm Connie Empress, Communications Manager here at New Buildings Institute. Before we begin, I have a couple of housekeeping things to tell you about. First, you are muted and we cannot hear you. This helps keep the background noise down so that everyone can better hear the speakers. I want to direct you to the dashboard that you should be able to see on the right-hand side of your screen. If you are having technical difficulties and cannot see the slides or hear our speakers, you can use the question pane in this dashboard to let us know, and we will help you as we go. We will take questions at the end of the presentation. Please ask questions in this same question pane. Please take a moment to answer the survey at the end of the webinar. We consider your input in the planning of future sessions. If you are seeking AIA credits, this survey is where you will share your AIA number for credit submission. This session is being recorded. All registrants will receive an email tomorrow with links to the recording and slides for the session. If you need a certificate of attendance for your records, it will also be part of tomorrow's follow-up. Let's see. As I mentioned, these sessions are from the 2019 forum. The 2021 forum is coming up about a year from now in New York City. So you can sign up on our website or follow along on gettingtozeroforum.org for updates on our progress. A little about NBI before our session begins. This is our theory of market change in our mission to make buildings better for people and the planet. And here are today's panelists. I will turn the mic over to Clay Nessler, Vice President of Global Energy and Sustainability at Johnson Controls. Clay?
Thank you, Connie, and good morning, good afternoon to everyone. It's a great privilege and an honor to participate with the other panelists on this webinar today. What I'm going to do is, for the last couple of years, I have shared data from the Energy Efficiency Indicator study to the NBI Getting to Zero conference participants, and I wanted to provide an update of data that was taken in late November, early December of 2019. Now, for those of you like me that think December 2019 seems like 2 years ago because of the COVID pandemic, it was in fact before we had really understood the significant challenges that the coronavirus would provide. So look at the data from that context, and then I'm going to provide a sneak peek of research we just completed 2 weeks ago that would be during the COVID pandemic. Next slide, please. So this is the 13th edition of the study. It's a global study with 1,400 organizations represented around the world. I'll be sharing results of the US study. And one thing we did this year at the suggestion of NBI is to do a regional analysis. So instead of an aggregate of results, we've used the census groupings of the 4 major regions of the US. Next slide. So the key question everybody waits for is what percentage of organizations plan to increase their investment in energy efficiency, renewable energy, and smart building technologies? Back in December, 75% of organizations across the US were planning to increase investment. That's a 10-year high. So this would have been a really great year for energy efficiency and clean energy technologies in buildings had it not been for COVID. You see here, it's pretty evenly distributed between the regions, and actually the greatest level of investment was going to come in the South. Next slide. One question we ask is organizations, what did you invest in the last year? And there's about 25 different improvement measures. People generally get this right because they know what they invested in. Again, these are facility leaders in commercial, institutional, and industrial sectors. The other question we ask is, what do you plan to invest in over the next year? The winner this year was behavior and education programs. HVAC and building controls are kind of perennial favorites, usually at the top of the list. Electric energy storage actually ranked fourth, with 59% of organizations planning to invest in electric energy storage. As you can imagine, this question 10 years ago, if we asked it, would have been incredibly small. So you see this particular clean energy technology rising to the top. Building systems integration and demand response and demand flexibility investments, over half the organizations investing in that. Next slide. So the question we have been asking for 13 years is, do you have a green certified building, or do you plan to have one over the next 10 years? This data has continued to rise, and in fact, a 4% increase on average over the previous year. And here you see, again, pretty even distribution, with the South actually having the highest percentage of already achieved and plan to achieve. Next slide. Now, this is the question that we have started asking over the last 4 or so years and is most interesting to the NBI organization and participants at the conference. And that's, how likely are you to achieve a net zero facility? It could be net zero carbon, net zero energy. It could be near zero, which is the term used in Europe, and this is a global survey. So we give a series of synonyms, if you will, for super high performance buildings over the next 10 years. This went up significantly over the past year. 67% in the Midwest, 70% in the South. And what I found surprising is I expected the coasts, the East, Northeast, and the West to be the highest percentage, but actually higher percentages in the heartland of the United States and the South. Next slide. One thing we did this year is because we had so many organizations planning to achieve net zero, we had 2 very large populations. Those that are planning to be net zero and those are planning to be not zero. So we did a little analysis looking at what are the different investments between these 2 populations, about 200 organizations each. And I think these results are really interesting. The greatest difference is 17% more organizations plan to invest in demand response, demand management, demand flexibility. That was the greatest. Distributed energy resource integration into building systems was next. Thermal energy storage. What was surprising is that
okay, I found this on the web. Whereas a synonym over the next 10 years.
Sorry, Siri thought I was talking to her. So sorry about that. Siri looked up high performance buildings. Anyway, thermal energy storage ended up being very high. Electric battery storage was ranked so high in both populations, it didn't make this list. Non-renewable distributed energy generation. So that's an interesting question. Why would organizations planning to be net zero energy or carbon invest in fossil fuel-based distributed energy generation? I'll tell you what our hypothesis is and some data to support that hypothesis. Mobile occupant interfaces, which provide direct information from the building and to the building, controls HVAC, lighting, and renewable energy. So next slide. So our hypothesis is that there's a tremendous overlap between organizations that plan to have a net zero carbon or energy building and those that want to be able to operate off the grid and are focused on resiliency. When we tested the hypothesis, R squared, or correlation coefficient, of 0.66, which is a moderately strong correlation between those organizations. So organizations that are driving towards net zero also keenly interested in resiliency and long-term operation off the grid, and investing in fossil fuel renewable energy, probably CHP, cogen, things like that, in addition to the more clean technologies. Next slide. So here's one key question. We asked among the measures, how many of the organizations replaced a fossil fuel heating system with heat pumps in the previous 12 months? We were again very surprised at this level. 35% in the West, 36% in the South, in the mid-30s everywhere across the country. Generally, people believe that one of the curses of energy efficiency and green buildings is that people wait for stuff to break. They wait until a piece of equipment fails, then they replace it. And unfortunately, some of the least efficient equipment tends to last too long. Proactively updating, replacing things like fossil fuel heating with heat pumps, replacing HVAC, replacing controls before end of life is one of the trends we see increasing over the past few years, and I think that's a very positive trend. Next slide. So this is the sneak peek. About 3 weeks ago, we finished the 2020 energy efficiency indicator, and we asked a number of new questions that relate to the coronavirus and investments as well as impacts. And I couldn't resist the temptation to give you a peek at the results. One thing is the percentage of organizations reporting that improved occupant health and wellness is extremely or very important, increased from 62 to 74%. Not surprised at all of that. One of the highest rated drivers for investment, 81% said that increasing the flexibility of their facilities to quickly respond to a variety of emergency conditions like a pandemic, natural disasters. Think of wildfires on the West Coast. Think of tropical storms. We have yet another hurricane hitting New Orleans, third time this year. That type of flexibility is extremely or very important. I would encourage everyone, as they're thinking about high performance buildings that are net zero, they also need to be resilient and healthy and safe. Next slide. Here's a sneak peek at what organizations have already invested in, which would be the dark blue bars, and the light blue bars are the percent that are planning to implement in the near term. You see things like, and these are not just facility related initiatives, increasing work schedule flexibility. I think we're all experiencing that. Indoor air quality assessments, about 70% have already implemented that within their organizations. Being able to remotely scan for increased temperature, skin temperatures. Certainly at schools and other facilities, those systems are in place. Reducing occupant density, social distancing is important. The more mechanical oriented things like air filtration, installing air treatment like UVC air treatment, as well as increasing outdoor air ventilation rates. Also very popular improvements, somewhere between 40 and 50% already implemented, with many planning to implement in the future. And I believe my final slide is this. This is becoming a really big surprise, but data is supporting it from all corners. Most buildings, say office buildings in New York City, are or were at their bottom, about 4 to 6% occupied. And what's been surprising is how little the energy has dropped. And so we asked a question about that for your facility portfolio. How much has energy use changed during the pandemic? And what you see here is that a few increased, actually religious facilities actually increased, which I think you can think of some scenarios in which that might be the case. Windows open, doors open, conditioning tents, things like that. But the majority decreased less than 10%, or certainly less than 90%. Only 8% decreased in energy use more than 20%, which is surprising considering the significant change in occupancy. I think what this is teaching us is that as we're adding flexibility to facilities, we need to be able to dial down. GRES portfolio of buildings, which tend to be higher performance and greener, are doing better. They're in the 30 to 40% range. And anecdotally, net zero buildings, which really control plug loads and really control at an individual occupant level, are able to dial down even more. And I think this is a key attribute in all high performance buildings in the future. So that ends my sort of update presentation here. And now I'd like to introduce our next panelist. Shanti Plus joined the Commercial Building Research Group at NREL in 1999 with a focus on applied research and design processes for commercial building energy efficiency and building integrated renewable energy. He's leading the development of the next round of advanced energy design guides and managing the whole building systems integration section of the group. Shanti, over to you.
Thanks, Clay. Welcome all. And I kept my title slide from a year ago here. This is a subset of what we talked about from a year ago. So well, 10 minutes to quickly go through what we saw a year ago. I probably some new updates since then, but kind of set the stage for the remaining speakers to kind of think about and talk about the future of energy efficient buildings and as the grid changes. You know, I think as a building energy efficiency researcher, I spent 20 years focused on things like zero energy buildings and zero energy design guides and really aggressive energy efficiency. That was all about kind of saving as much energy as possible, any time of the day, any time of the year, and netting out kind of your renewables over the course of a year. And that was kind of the first generation of net zero energy buildings we've all been working towards and on. And you know, looking for the next 20 years, how is that going to change? And so the key kind of element that we are looking towards is how this new era of cheap renewables on the grid will change, and how the future of buildings and future of zero energy buildings will have to what's their role, right? And that's kind of what I talked about a year ago. So let's see here. And you're starting to see these types of studies really start to make it clear, right? That when the full life cycle costs of buildings and building and operating renewables on the grid have dropped below the operating costs of conventional generation. So it's cheaper to install new solar, wind, and storage than it is to operate existing facilities. That's definitely a tipping point where we're starting to see significant amount of new renewables, low cost, significantly cheaper than existing assets start to really be the future on the grid, right? And so, and then regionally, you'll see places like in LA, right, where they're getting new PPAs for new solar, large scale utility scale solar under 2 cents a kilowatt hour. So that's kind of the cost to install that new solar to them over the course of a 25-year power purchase agreement, right? And remember that 2 cents a kilowatt hour. You look at, historically, this is now 2 years old, and the new Lazard life cycle cost of energy data just came out this week. That data continues to show these cost declines from residential all the way through the utility scale, large scale PV that that they track, and so continue to see those costs. Wind, solar, wind and storage are also have similar cost declines, right? And so I'm in at NREL in Colorado, and so we kind of track what's happening locally pretty closely just to get a sense of it. And our utility here, Excel, is planning to install new generation, right, and put out an open source bid. The average what they got back was 1.81 cents a kilowatt hour for a combination of solar and wind and storage, right? So that kind of started to open our eyes up, and then they went back and got some more firm bids on those that open source call, and what solar storage at 3 cents at 3 to 3.5 cents a kilowatt hour, wind lower than that, right? And so this was we're starting to see these projects be put in place, and that's really driving for us commitments statewide to get to 50% renewables in this next few years. And as large utilities like our utility here in Colorado, Excel, or others are now making these commitments in this past year, they've committed to 100% carbon-free electricity by 2050, right? And so it's becoming, as they see these cost curves And this is kind of where the macro scale seems to be going on the grid. As an energy efficiency researcher, for all of us that have spent the last 20 years trying to figure out how to get utility efficiency programs in place to be able to take advantage of historically the lowest cost of energy, right? The energy you don't use. These programs run about 4.5 cents a kilowatt hour, a combination of the cost for the participant and what they spend on their efficiency and the cost for the utility programs. And so if we're installing new renewable generation at less than this, it's starting to make us in the energy efficiency industry start to figure out how we participate. And we think about will typical utility efficiency programs go down, right? There's significant investments over the years in those, right? And that saving energy in in hours of high renewables on the grid, where the marginal cost and the marginal carbon on the grid is maybe negative, it's maybe not so much of a benefit anymore to save energy at all times, right? Like we used to talk about, so kilowatt hour savings anytime, any place, now becoming important for us to think about kilowatt hour savings at the right time in the right place. And so as we transition that thought, I think this concept of what the demand flexibility in buildings and what the Department of Energy and others are now talking about is grid interactive efficient buildings, GEB, as a concept to start to value demand flexibility and responsiveness to the changing of renewable content on the grid. And as Clay mentioned, zero energy enhanced on-site resiliency is definitely going forward, making the case for better demand flexibility and storage integration. And from a simplistic point of view, and you look at the grid where you've got high net load in the later afternoon, say in California, with low renewables on the grid and significant low net grid demand hours in the middle of the day, right? That's starting to create some simple ideas around moving that load on those peak hours later in the day for your utility. Every utility in the United States seems to have a different version of this, whether it's a wind-dominated grid or solar storage, when your wind peaks seasonally. So understanding how your utility is adding renewables and what that resource looks like, and it will then allow you to think about your demand profile. And I think it's for me, it started to become real when I saw major tech companies like this one. They've a long time ago committed to 100% renewables, right? So they bought a bunch of offsite renewables, had owned a lot of offsite renewables, and netted out where they owned or purchased more offsite renewables than their loads in 2017 actually, right? And so, but then they started realizing what's next, and for them it was about how to match their renewables on an hourly basis with their loads. And this is the idea of 24/7 carbon-free energy. So they've spent the last couple years now trying to figure out how to do that, how to reach 100% renewables 100% of the time. And so to me, going forward for buildings and to have net zero energy goals, starting to think about how well on an hourly basis your load matches your renewables so that you can target this goal of 100% renewables 100% of the time is in line with what some of the big tech companies are starting to think about. They do things like move compute in their data centers around to different parts of their facilities where they have high renewables for every hour, and if there's a high mismatch, they can move some of that compute to other data centers that have a lower mismatch. And so really innovative strategies are starting to come out that are now targeting this goal of 100% renewables 100% of the time, and that's renewables either in your building or on the grid, right? You're trying to match that. And so to me, it's a quick snapshot, and this is kind of what it looks like on a scatter plot when you look at over the course of a year, every hour in the year, where the green is 100% match for that hour, and the black there is no match, right? You don't have any renewables locally and so this is 69% of the hours they're aligned, right? And so there's a target here of 100%. Netherlands data center. You go to a North Carolina data center with mostly solar driven, you get some good midday match where you're 100% for the peak in the middle of the day, but because it's solar driven storage and other renewables are become part of the solution. So quick snapshot how I see it, just kind of the emerging renewables on the grid. Happy to, there's my contact information. We'll talk more at the end and what that means for electrification, what that means for our favorite topic of electric kitchens and electric heat pumps.
Great. Thanks, Shanti. Very, very interesting presentation. I love the idea of matching the grid 24/7. And I think efficiency has a really important role in that as well. Instead of just using efficiency as base load, if you will, being able to take advantage of efficiency in the right places and at the right time. So really appreciate that. Our next speaker is Ram Narayanamurthy. He is the technical lead and program manager for advanced buildings at EPRI. He directs research in the areas of building decarbonization, building flexibility, and smart, sustainable, and resilient communities. He developed the first zero net energy neighborhood and is developing zero energy affordable housing communities in the Central Valley and Southern California. Ron, over to you.
Thank you, Clay, and good morning, good afternoon, everyone. This Shanti and Clay, I think, gave a great overview and a bird's eye view of where we are going. Trying to compress 30 minutes into 10 minutes, I'm going to focus on, hey, what are the key questions as we try to actually make these things happen? I used to have this presentation just called Affordable Decarbonization, but being in Northern California, resiliency of homes and buildings is becoming more and more critical. So how do we look at this as a affordable and resilient decarbonization journey? I'll skip through this. EPRI is a nonprofit, not-for-profit research organizations. We work around the world, working with utilities around the world, and we do research all the way from generation to customer end use. So when we talk about building decarbonization, and this perspective has been changing over the last few years. So we started with, okay, hey, let's go all electric, see how that works. What can we do to get all electric? Because we know that the grid's going to decarbonize in 30 years. So if we can do all electric today, then we are pretty much set for getting to that zero carbon building stock in the next 20, 30 years. Choose your target. But as we started doing more and more of this, one of the things that we started thinking about was, should we try to decarbonize? Should we try to electrify everything all over the place today? Or how do we actually approach this as a staged hybrid pathway so that our goal of getting decarbonization by 2040, 2045 stays? But is there a more customer centric pathway that will help us get there in a more customer centric way? So from a customer perspective, we have to preserve the functionality. How do we enable more comfortable homes? How do we enable a more healthy home? How do we enable more healthy commercial buildings? How do we provide resilience? It's becoming a bigger and bigger issue. Clay just talked about the hurricanes in the Gulf Coast. The wildfires are in Colorado, where Shanti is, in Northern California, where I am, and Richard is. So it's becoming a bigger issue. And how do you decarbonize affordably? Which is, do we have all the technologies and the pathways to be able to apply them today and do it in a manner that's cost effective? And finally, how do you preserve future optionality? Technologies are going to evolve for decarbonization. How do we preserve that optionality so that we can do the no regrets measures today, but then in the future have some optionality where the harder to achieve goals, we can actually use that, keep that for future technologies. So that's the approach that I'm going to take in the presentation. I'm going to run through very quickly through some use case, some of the field demonstrations and the learnings from those, and hopefully we leave with more questions than answers as we go through the presentation. I'll be going quickly through some of those. We talked about some of the zero carbon communities. Clay already talked about it. I'll skip through this. There's a lot of work that we do in actual field implementation, especially working with affordable housing and multifamily communities. We do a lot of work in single family new construction. So there's a lot of lessons learned in actually applying these technologies, not just from a technology analysis or a lab perspective, but what happens when you put technologies in the field and customers interact with them. Again, a whole range of different types of smart communities that we work on. And finally, when we get to the state of electrification of existing buildings, what do we run into? We run into supply chain markups, panel upgrades. We can't have availability of heat pumps in some places. We have issues like direct buried cable, where the electrical infrastructure is not ready to have electrification. We run into things like asbestos mitigation as you try to punch through walls in 50-year-old buildings. So all of these issues start popping up as real-world costs and barriers when you start addressing electrification. So what have we learned, right? Quick summary: heat pumps. One of the biggest things that we see in heat pumps is that there's a supply chain issue. Manufacturers don't work directly with the end customers. There's distributors in the middle. A lot of the areas, the distributors are not ready. There are markups on heat pumps, all of which makes it harder to electrify because the end customer ends up seeing an increase in cost, or the supply chain's not ready. So one of the things that we look at is, okay, hey, what happens if every air conditioner sold starting today is a heat pump? What will it take to get there, right? So that's almost like a no regrets approach that we would love to take. And so some of the results from heating electrification, one of the things we want to emphasize here is that deep efficiency is an enabler to electrification. In many places, if you electrify and you do the fuel switching, customer bills are going to increase if you don't do the efficiency. This is an example where we worked on an existing affordable housing community. It is Southern California, so the heating loads are lower, but because of the deep efficiency, in this case, we were able to reduce the overall net electrical usage, even with electrification of heating. And that's because with insulation in the roof, adding insulation in the wall, replacing windows, you're able to substantially reduce the cooling load so that the reduction in cooling load overcomes the increase in heating load in the winter. So deep electric efficiency, the other advantage of deep efficiency is that you also reduce or avoid backup resistance elements, which are a driver for grid impacts from electrification. Quickly running through this, some of the solutions that we've been working with, for example, when you start going into existing buildings, you don't have enough electric infrastructure. One example of the solutions that we've been working with is 120-volt heat pumps. These are brought in from Italy to replace existing evaporative coolers. There's not enough electrical service in this building to go to standard heat pumps or heat pump water heaters. But the good news is we were able to get them in, get the data, looks like they work well. So it's looking at this optionality, looking at technology options that can help us overcome these barriers. Key takeaways, I think wherever you have air conditioning, let's try to change that over to heat pump retrofits. And there's the heating electrification also captures significant carbon savings. Heat pump water heaters. Here, it's more about, I think, aligning the products to the markets. We have a lot of products today, but what I would like to encourage us to look at is this multi-pronged decarbonization strategy for water heating, which is combining efficiency, renewables, for example, solar thermal, and electrification. How do you put them together so that you can have a more integrated, more affordable, low carbon solution for water heating? Upgrading water heating, we run into some significant costs, especially on the electric distribution side, things like panel upgrades, extra wiring for 240-volt elements, replacing 40-gallon water heaters today. There's not a 40-gallon heat pump water heater, so you end up with construction costs. So there's a lot of different costs that you run into when you try to take existing products and try to fit that into market segments like multifamily. So how do we address that? One of the things that we would like to look at is also things like beachhead strategies, which is, hey, can we go first, address all the electric resistance water heaters, replace them with heat pump water heaters so that you scale the heat pump water heater market. The heat pump water heater market today is about 85,000 units nationally, which is about 1% of the national market. So how do you scale new technologies like heat pump water heaters? What are the beachhead strategies that can give you carbon reductions today? Other retrofit approaches is looking at hybrid approaches. Can we have Europe and Asia have a lot of these smaller form factor heat pump water heaters? Can you use them in conjunction with existing water heaters so that you can reduce the cost of retrofits, but at the same time take maybe 70–80% of the energy use from fossil fuel to electrification. So it might make sense as we go through this to think of it as, can you, instead of trying to take 100% and convert 100% of heating energy use but you can only reach maybe 5% of customers, would it be better to take out 70–80% of heating energy use, but you're doing it across 30–40% of customers? So these are the types of hybrid approaches that we are starting to look at. Of course, these are very early days, but the question is, hey, what can we do? What can we do today that's cost effective, that's resilient, and takes out a substantial amount of carbon, knowing that in a few years, in a decade or so, we can come back and sweep up the rest of the remaining carbon in our buildings, but have the option for new technologies or new approaches in about a decade or so. Finally, looking at how do you aggregate customer resources? Yes, we can do electrification. Shanti talked about how to do that 24/7 carbon free. So aggregation becomes a bigger play. And so there's work going on in terms of how do you aggregate end-use resources and end-use loads. And finally, where do we see the highest potential for flexibility? Smart thermostats are a great option. They are very inexpensive. They can go on existing buildings, existing air conditioning systems. And research has shown that there's substantial flexibility to be gained through pre-cooling and other adaptive strategies that are customer-centric with smart thermostats. The other area, EV charging management, it's more in the development phase, but EVs, especially as we get into grids that have high carbon intensities in the evenings or the nighttime, having EV charge management might be critical to be able to provide your decarbonization. And finally, summarizing, what are the takeaways from the presentation? A, consider the customer. What is important to the customer? Affordability, resiliency, and carbon savings go hand in hand. So reduce first cost. No regret strategies include things like targeting heat pump replacements, being able to do deep efficiency. Efficiency is a no regret strategy to decarbonization. Let's scale that today. Let's look at things like 120 volt products, so that can both reduce cost and increase resilience. We need to get more transparency on cost and bulk purchasing so that we can reduce the cost of electrification where it makes sense. And let's try to electrify in an appropriate manner. We could leave gas backup or look at dual fuel heat pumps, for example, to avoid both to avoid grid upgrades and provide customer resilience. So with that, let me turn it over to our next speaker. And back to you, Clay. Thank you.
Thank you, Ram. That was a great presentation. And it was exciting to see some of the 120 volt heat pump technology coming in from Europe and being applied in these very challenging environments from both a cost and an installation perspective. So really appreciate that overview. I feel more optimistic that there are pathways towards decarbonization that would leverage existing infrastructure and bring in electrification at scale. Our last panelist is Richard Young. He is the director of the Food Service Technology Center, a publicly funded energy efficiency research facility operated by Frontier Energy and known to most industry insiders as Fishnik. I'm sure there's a story behind that, but I don't know what that story is. What an interesting name. Richard is a former member of the National Restaurant Association's Conserve Advisory Council and is a past fellow of the Hobart Center for Food Service Sustainability. Richard, over to you.
Clay, thank you so much. Hello, everybody. I'm going to talk a little bit about kitchens, and I'm going to cook through my slides today because we have a lot of information to do in 10 minutes. Before I jump off my title slide, though, I do want to thank PG&E's Workforce Education and Training Program for sponsoring my time this morning. I also want to point everybody to the website at the bottom of this slide, caenergywise.com, where you can get loads of this training for free off of that website and follow up with this information. There we go. Yes, fishnick.com. Oops, let's go back one. There we go. This is a little, okay, fishnick.com, Clay, for you. The two people that founded our project, the Food Service Technology Center, 33 years ago were Don Fisher and Judy Nickel. Hats off to Don and Judy. They gave, you know, their heart and soul to this project. And so our first website was Fishnick, and in honor of Don and Judy, and it just stuck. Nobody can remember the Food Service Technology Center. Everybody can remember fishnick.com. So there you go. So I want to start our discussion with a story about a real restaurant. It's a small chef-owned restaurant, independent restaurant in Pleasanton, California. Superb place to eat. If you ever come out and visit me in San Ramon, I'd love to take you there. So the chef, Chef Matt, who was trained at the Culinary Institute and cut his teeth in fine dining in New York, wanted to start his own restaurant. And if he had just done what he learned at the Culinary Institute and in these, you know, high-end New York restaurants, or gone down to the local equipment dealer, he would have set his kitchen up with a very base efficiency cook line that was mostly gas appliances with a couple of electric appliances. Now, this cook line would have generated about 37 tons of CO2 a year, and it would cost him about $11,000, almost $12,000 a year, which is a lot of money to operate. And I have to let you know that this cook line is basically a 1950s design. It really hasn't evolved much. And in fact, this sort of very basic cook line is going into many of your high-end projects today. You may be building what you think is a LEED Platinum building, and it might have this kitchen in it. So food service, in many ways, is very behind. It's very typical to see this kind of unevolved technology. If we were lucky and Chef Matt had been connected to our utility energy efficiency programs, perhaps he would have bought some efficient equipment, some Energy Star equipment, and upgraded that line. In this case, his energy efficient cook line would have been generating about 25 metric tons a year, and the fuel cost would have been $8,000. And so what we've got there is a savings of 11 tons of carbon and almost $4,000 in operating costs. And let me tell you, for a small operator like Chef Matt, $4,000 is a lot of money. That goes directly to his pocket. He would have to sell roughly $80,000 worth of food at 5% profit to make $4,000. It is a very tough industry. And to to sort of touch on Shanti's point about energy efficiency, I would say in some of your more advanced buildings, energy efficiency, the benefits may be declining, but in an industry that is still really stuck in the 1950s, energy efficiency is absolutely the first and most important thing you can do to cut carbon in these buildings. So what happened in the real world, though, is that Chef Matt came into our facility in San Ramon and worked with our consulting chef, Mark Dusler, and took about 6 months to try out a bunch of different equipment. And because Chef Matt wanted to come up with something, a kitchen that was faster, flexible, a kitchen of the future. So we took Chef Matt from that sort of traditional 1950s kitchen, and we hooked him up with some really cool equipment like small half-size rack ovens, combination ovens, induction cooktop, super high efficiency griddle, and high-speed ovens, which allows him to do more food production in a more consistent way with less labor and in less space. That's really the kitchen of the future. So here's the kitchen that Matt actually ended up with. It's still a hybrid because it's still gas and electric, but now we're looking at a CO2 of 13 tons a year and fuel cost of $4,000 a year. So we have dramatically reduced our CO2 and our fuel cost. We've saved 24 tons off of that base case and almost $8,000 off of Matt's operating costs. So that is pretty amazing. And this is actually the kitchen that is installed in Saltcraft in Matt's facility. It is the best economic return for his dollar with the most reasonable carbon savings. And the point being that we have to keep Matt in business. We have to keep his cost to operate low. Half the restaurants out there are owned by independent operators. And as you might realize, half of those restaurants have probably, perished because of COVID. So this is a very strained industry, but it's also a $900 billion industry. Most of the unemployed people in the United States right now are former hospitality workers. And so this is an industry that we cannot just stomp on. We really have to work with them to try and rebuild them. Now, had we been able to take one step further and take Matt's kitchen all electric, we could have gotten his CO2 generation down to about 5 metric tons, and that's based on PG&E Northern California CO2. It's worth noting in other parts of the United States, the all-electric might have made his carbon go up, but in PG&E they have very, very low carbon power, so 5 metric tons a year, but his fuel cost is now at $9,000 bucks. So our CO2 savings are 32 tons. That's huge, and our cost to operate savings are still a couple $1,000s better than that base efficiency kitchen. So that's good news, but that did add some cost to operate back onto this kitchen, which may or may not be feasible. If we valued carbon, if we paid Matt to reduce carbon, then the all electric kitchen would absolutely be the best way to go, right? But we're still charging Matt based on kilowatt hours, time of use, all of this kind of good stuff, demand. And so this kitchen is really not affordable for him, although it's totally affordable for your Googles and your Microsofts and everybody, all your big high-tech folks. This kind of change is, increased cost is a drop in the bucket. And in fact, as I said, it's a savings over the base kitchen. So to summarize that, if we look at our, base efficiency kitchen, this is the one that's typically getting built, 1950s kitchen. If we can convert people over to just a high efficiency kitchen, we dramatically reduce our carbon. So what we're seeing is the green bars are the cost to operate, and then the gray line is the carbon. That's my axis on the right, my y-axis on the right. So we dramatically reduce carbon and cost to operate just by getting people to go to high efficiency equipment. That gets us really to our 2030 carbon goals. But let me tell you, that's like moving the mountain. When we show food service people the third bar, the hybrid kitchen of the future, they're all like, well, that's the one, let's do that. Lowest cost to operate, very low carbon. The challenge is most people in the food service world have no idea how to do that. Even the highest end engineering firms have no idea how to do that. Sadly, most of that knowledge, lies with us at the Food Service Technology Center, our little crew. So we encourage you to contact us, work with us. You don't get to the hybrid kitchen of the future without some real thoughtfulness. It just doesn't happen. And then of course, there's the electric kitchen of the future. Our cost to operate rises up, but the good news is if you put in that engineering time, you can still make your all electric kitchen operate at a lower cost. So a couple of realities. Full electrification is not currently economically feasible for many commercial kitchens. I used to have most, but I would say it's many, particularly with this audience. A lot of your bigger facilities can do all electric, but you really need to come work with us and do it right. I've seen some all electric projects go down the tubes because people modeled them improperly. And really to really make this happen, we need some economic policy, grid system changes. The food service industry falls right on a lot of these high demand periods. We need to figure out how to work with them. And then reality number two, significant decarbonization is achievable immediately by upgrading to energy efficient gas equipment. I mean, that backs up what Ram is saying. It's a staged process, and there is so much low hanging fruit right now that we're not getting to that we really should be hitting that. And just to put it in perspective, if you took all the money that's been spent on energy efficiency programs over the 3 decades that I've been in this business, it equals about 4 days worth of the energy bill for the food service industry. We have put 1 grain of sand on the beach into this process, and we're way behind. So our electric challenge, electric appliances cost significantly more to operate. So you have to design smart. You can't just do a 1-for-1 swap and think you're done. And designing smart means you go to the smallest piece of equipment, coffee brewers, conveyor toasters. This is a study we did for the California Energy Commission. You can go look this up at fishnick.com, CEC plug. And it shows that you can save, 1/3 to 2/3 of the energy on all of these standard little countertop pieces. So the smallest systems all the way up to the bigger systems like the kitchen ventilation, we need to do demand control kitchen ventilation. We need to make that a standard. And any technology that can reduce your, power, your average by 57% across a wide variety of kitchen types, that's something we should be using right now today. And then heat pump water heaters. This is the biggest challenge I see. The problem is that we don't have any data, field data on heat pump water heaters in commercial food service, and we need to do that. And we're working to try and get some studies, but if anybody wants to work with us, come contact us. We know a huge amount about water use in commercial kitchens, and we know that most of your facilities are designed improperly. If you want to do heat pump water heaters, you have to do a change in your plumbing design, you have to go to deep centralized water heating and heat recovery dish machines. But there's a bonus. There's a lot of waste heat in the commercial kitchen, so that's a good thing. And let's see. So what do we have? Let's get back. Whoops, that's my 10-minute timer. What do we have? We have lots of equipment choices, and we have the Food Service Technology Center as a brain trust. What do we need? We need more equipment testing. We need more data for design to make this happen. We need a lot of hands-on education and industry outreach. The industry, this massive $900 billion industry, is somewhat blind. And we need policy solutions that consider the operators. We just can't force these small business people to jump into all electric without giving them a positive ROI. And with that, I'll say thanks, and I turn it back over to Clay and Connie and for some Q&A.
Great. Thank you, Richard. That was really inspirational. It was great to see all the knowledge and expertise that your center has accumulated and the ability to keep Matt in business. I definitely want to visit that restaurant. And it's really refreshing to not have cost or carbon, but you showed great scenarios where there's efficiency, there's space utilization, lower cost, and much reduced carbon. So great presentation. Now I'm going to turn it over to Connie to lead our Q&A.
Okay, thank you, Clay. We had a question. Our culinary, this is for Richard, our culinary schools like the CIA teaching about energy efficiency in kitchen equipment?
The Culinary Institute does not really teach about energy efficiency. They have invited me to come speak. In fact, the very last presentation I gave on, I think, March 13th, right before lockdown, was at the Culinary Institute in Napa. And they are a great outlet, and I think they want to get more into this, and they are moving into the all electrification area. But there's still very much a barrier between what we do as energy efficiency professionals and what's taught in the Culinary Institutes. And I would suggest that above and beyond the Culinary Institute, because we all tend to look at the CIA and the foodie chefs and the high-end chefs as like the be-all end-all, but you know, they're less than 1% of the industry. What we really need to be doing is going after all of the culinary programs in high schools and community colleges and university registered dietetics programs, which we've worked with for a lot of years in Northern California. So that's the place. And we actually have some online training that we're trying to push through these various sectors that really puts virtual Richard Young in some classrooms.
Awesome. We actually have quite a few questions for you, Richard. Kitchens are obviously the hot topic today. So we had our clients are interested in electric kitchens, but have significant concerns to the impact of the food quality. Are there concerns about that, Richard?
You can basically you can do almost everything on electric that you can do on gas. It does not really affect food quality. There are a couple of situations, you know, one really in particular that I can see that can't be completely replicated with electric appliances, but you can actually change your processes to get the same food quality and food taste. Going all electric is not the technical challenge. The technical challenge really comes down to the hot water supply. That's what we see as being the biggest challenge. But you know, if you've been on a cruise ship, it's an all-electric kitchen. It can be done. But what I do encourage people to do is contact us, because this is an issue. And what we find is that when we bring people into our demo center and have them actually work on the equipment and work with our chef, they overcome these barriers. You know, as I said, Chef Matt, he worked, you know, for the finest restaurants in New York, and he grew up on, you know, a gas range. And yet when he came in and he used our induction cooktop, he was immediately sold. And it took his staff exactly one day to be sold on the induction cooktop.
Okay. This is a general question for all of you. Our listeners would like to hear more about hot water technologies to watch, stuff that's on the rise.
Well, as I mentioned, you know, in the food service world, it's heat recovery dish machines. That's what's going to make your heat pump water heaters work in a high hot water draw situation. That's really what you need to look at. Point of use hot water distributed hot water heating, redesign of your plumbing, but especially heat pump water heaters. Heat recovery dish machines to work with your heat pump water heaters.
Hey, Richard, does that have a heat pump in the unit itself, or is it just recovering drain water heat to preheat water coming in?
There are a couple of different kinds. The smaller ones are actually not capturing the drain water heat. They're actually capturing the heat that's coming off of the rinse cycle. So they're capturing the heat at the top of the box instead of the bottom. The bigger machines actually do have heat pumps built into them, the bigger conveyor dish machines. So, and then there's one machine that actually has the heat recovery from the rinse water using the heat pump, and it has some drain water heat recovery. So multiple sizes. They're very complicated systems. Yeah.
Maybe
One of the trends
I'll
we see.
chime in too.
Oh, go ahead, Ron.
Oh, okay. So I was just going to quickly say, I mean, on hot water heating, I think the CO2 systems are going to be critical because I think there's a need for efficiency to make it cost effective for the customer. So things like the Sanden or the Mitsubishi units coming in from Japan. And the other area that we are anxiously watching and excited about is 120 volt systems that can be used as retrofits in existing homes and buildings.
The only thing I would add is at larger scale commercial and institutional buildings, both Europe and the Asia Pacific countries are innovating with heat pump technology. One, a lot of projects like hospitals and Stanford University, for instance, their central energy facility, use heat recovery chillers. So the primary task of the equipment is to chill water for air conditioning. And then rather than exhausting the heat through cooling towers, the heat is recovered. And that can provide a large percentage of the required heating, about 90% at the Stanford campus. But there is some new technology being made available in Europe and to some extent in Asia as well, so-called four-pipe systems, which can simultaneously control the temperature of the hot water as well as the temperature of the chilled water. So it isn't cooling with a little bit of heat, or it isn't heating with a little bit of cooling. It's actually being able to control both circuits. And that becomes a really interesting technology for replacing a fossil fuel boiler and a chiller in a large central plant or a district cooling. Heat pumps are also now able to deliver much higher temperatures at an industrial scale. And some of this technology is being used in district heating systems where they're recovering waste heat from data centers and other processes and boosting it up to high temperatures to augment what used to be boilers and providing that. So there's a lot of interesting technology development in heat pumps, both at the 120 volt scale, a single user, up to very large city scale district energy.
Yeah. Mind if I jump in too as well? So ASHRAE just renovated their headquarters in Atlanta. Everyone knows ASHRAE, right? And it has a smaller scale version of that heat pump chiller. So it's an all electric chiller, does the air, chilled water as well as all their hot water for their radiant system in their headquarters. So great example of ASHRAE is doing that in their climate zone. But that's Atlanta, and so I think as we try to electrify in colder climates, the concern of how do you pull heat out of air that's below freezing to do heat pump hot water heating becomes a technical challenge. And so there's some great kind of cold climate heat pumps that are now becoming available to be able to pull heat out of, say, minus 20 degree air, right? And still do meaningful lift on a heat pump hot water heater. So those technologies to me are pretty exciting. It broadens the applicability of air source heat pump hot water heaters for outdoor units, like the ones that Ron was talking about. And then finally, as you get into domestic hot water systems for, say hotels or multifamily buildings that have a fair amount of warm water that leaves the wastewater system of the building, there are some good technologies out there at the building scale and the district scale that allow you to pull heat out of that wastewater through a water-to-water heat pump that allows you to then heat your domestic hot water that way. So you don't necessarily have to pull heat out of minus 20 degree air if you have the wastewater flow necessary to provide for that water-to-water heat pump. So those technologies are, to me, are expanding the use of heat pump hot water heaters in more climates and more building types for sure.
Awesome. Well, we're just about out of time. Just click through my last couple slides here. You can visit the gettingtozeroforum.org resource hub for 300 zero energy and zero carbon resources across 6 different topic areas. We have another webinar coming up on December 3rd, Getting to Zero and Affordable Multifamily Housing. Those are available at events on our website, and we have another series starting in January, so stay tuned. And thank you so much. You will receive an email tomorrow with links to the on-demand recording and a PDF of these slides. Thank you very much, Clay. Thank you, Shanti, Ram, and Richard for your time on this session. It was fantastic.
Thank you, Connie.
Thanks, Connie.
Thank
John.
you. Thanks, everyone.
Ram and Clay. Have a good one.
All right, everybody, stay safe and stay well.
Bye now.